So it's 314, 314, timestamp, timestamp. Okay. So Tim, maybe do a quick introduction of who you are and the role you play here at Blackfish. And what I'd like you to do is help answer the question for us of what is VMV, why is it important, and how do you do it? Does that make sense?
It does indeed, yes, right. So my name is Tim Warren. I am one of the co-founders at Blackfish Engineering, and I am the operations director. So I've got about 25 years worth of experience in multiple industries: aerospace, offshore renewables, rail, mainly in mechanical design and project management. So I have a lot of experience of many projects. Some have gone better than others, but throughout every project, the common theme is how do you ensure that the market is ready to accept the technology, and how do you make sure that you're not going to end up, as you can see on this slide, either with a Concorde, which is a brilliant product, but there wasn't really a market, there wasn't a market need for it, or you end up with a Titanic where the market doesn't have confidence in the system. And what I'm talking about now is a structured validation and verification process. We're going to use those two words quite a bit in the next few minutes. So what you can see here is that, does your product fulfill a market need? That's all about validation. And does the market have confidence in the system? That's all about verification. And I'm sure many of the people listening will be very familiar with these sort of fairly sort of high-level simplifications of a VMV process. Validation: did we build the right system? Is this what your customer actually wants? And verification: did we build the system right? So have you built what you intended to build? And what we can do is, in order to make sure that happens, is that we can go through a structured process called verification and validation. And again, I'm sure this is probably fairly familiar. This is a presentation that we put together and been through with clients and projects many times. But this is the structure of what we call the V diagram, and the V diagram identifies really everything there is to summarize what a verification and validation process is. So we start off at the top left-hand side of the diagram and we work down towards the bottom middle, and that is the design phase of the V&V process. And then on the right-hand side is the build phase, and that takes you from component build all the way up to a fully working system. So in order to start off doing what it is you want to do and build or the project, etc., you need some requirements. You need to know what it is that the customer wants in order for them to be able to say, yes, I'm going to buy it. Because if you haven't built what they want, then they're not going to buy it. So once you know what it is that the customer wants, you then have to design it. And it really helps to do this in a structured way at a system level. What is the entire system going to do? What are the system requirements? And design a system. And then depending on how complex your project is, to divide that into subsystem and component levels. And then as you go down the left-hand side of the diagram, you end up with a more thorough set of requirements at a smaller and smaller level. So then once you've completed all of your design phase, your component design, your subsystem design, and your entire system design, what you're then going to move on to is the right-hand side of the diagram, where you start to build and test. So you build at a small level, and then you build the small components into subsystems. You build the subsystems into a total system, where you're then able to complete a total system test. And at that point, you have a working system, which should, in an ideal world, be exactly what it is that the customer wanted. So how does verification and validation fit into all this? Well, the verification of system and subsystems is identified by the blue arrow. So when you do testing, the testing is there to verify that your design is correct. But once you've got a complete system together, what you're trying to do with the working system is to validate that what you should have been building to start with is what the customer wants. So there's the sort of the difference between verification and validation presented on the diagram. So the key aspect to this really is, well, there's a lot of key aspects to this. On the left hand, we'll treat this as a left hand and a right hand side, really. How do you know what it is that you need to design? And that's where requirements come in, and that's where I've worked on many projects over the years with customers, really to try and identify precisely what it is that the stakeholders and the customers want, and what the system and the subsystem and the component requirements are. Because if you don't know them, you don't know what to design. And if you don't know what to design, it gets very expensive when you get onto the right-hand side of the diagram, when you start building the wrong thing.
And that also slows down your time to market.
Oh, of course, yes. Yeah,
So it's not just about cost, but also about efficiency.
Yeah.
I think, in getting your system, your working system.
Yeah, absolutely. Absolutely. Yeah. Ideally, I mean, a lot of companies will thrive on the mantra of get it right first time. And understanding what it is you're meant to be doing is really all about getting it right first time. The right-hand side is obviously all about testing. And testing is, as we all know, the most expensive part. Building hardware and testing hardware and finding out whether the system works is far more expensive than the design and the analysis phase. So when I'm working with clients, we're presenting this, we're showing requirements, we're showing the plan as to what we're going to test. But what we really want to try and do is left shift on this diagram. So if we can move activities to the left-hand side and also down to the bottom of the diagram, we can reduce cost and we can reduce risk in the project. So a few examples of this. So if you can do some finite element analysis and prove that something won't break, instead of having to do a load test, that is significantly cheaper. If you can do finite element analysis at a small component level instead of the full system level, again, that's much cheaper. So the further down to the bottom left of this diagram you can achieve all of your verification and validation activities, the quicker you can get to market, the lower cost your project is going to be. And another really important aspect here is the activities that you do on the left are done before the activities on the right. So this is like a risk mitigation strategy. The earlier you can flush out the problems, the sooner you know about them and the sooner you can do something about it. If you find you've got a problem when you've just built your entire system, there's really very little you can do except start again. So the whole focus really, and when we work with clients, it's all about left shift on this diagram. Do as much as you can in advance in the design phase.
Yeah, and I think that's a really valid point, because many of our clients are technology innovators.
Yeah.
Whether it's grant funding or venture capital, there's not a lot of patience for doing things again if mistakes are made or overlooked.
Yeah.
So it really helps to increase investor confidence, I think.
I think so. Yes, absolutely. And once you've done all this and you've got a decent plan as to how you're going to validate and verify, it goes a long way to giving people investor confidence.
Yeah.
So I've spoken about going to validate and verify just the two individual things. It's actually a little bit more complicated because what we really should be doing is validate and verify on the left-hand side, which we call design V&V, and then we do the same validate and verify on the right-hand side, which is the build V&V. So when you've got system requirements, what we really should be doing is validating those requirements. How do you know it's correct? You really need to be either through stakeholder engagement or proof of or analysis of those requirements, saying yes, they are actually correct. I've looked at it. I know those numbers are right. And then you review your design against those requirements and verify that yes, I have actually got a design that satisfies those requirements. And so you can see the little mini loops there. So sort of mini loops of the V&V process. So it sort of ends up at the start of this set of slides. I had two banners which were validate and verify have we built the system right and have we built the right system. Actually, what a more thorough process involves is have you designed the right system by validating your requirements, and then verify the design. So have you designed the system right? And then, so that is the design V&V that I mentioned just a moment ago. And then the verification V&V process is all about, have you built the system right? And then at the end, have we built the right system? So it's a little bit more complicated, but not that much.
Yeah.
But it's really important to understand that and go through this process in a structured way. That can be quite iterative, but you need to go through that in a structured way.
Yeah, I think it shows that it's logical.
Yeah.
And like you said, structured. But I think it could also be considered overwhelming, particularly to companies that might not have a lot of engineering background behind them.
Or resource. It can be seen as time consuming if you don't know how to cut through the huge number of tools that are available. And when you look at systems engineering manuals, there's 100 different tools you can use. But knowing which ones are effective and knowing which tools to use and when and with whom is quite a skill. So and that's what we've been doing for years. And
it's another level of efficiency, right? So
absolutely, yeah.
Sort of scratching your head, wondering how to move forward, but just actually moving a technology program, R&D program forward.
Yeah, exactly. Okay. Yeah, so obviously that's a very brief overview of the V&V process. It's obviously come and ask if.
Yeah, thank you.
Come and ask us if you've got any questions or would like to know more.
Absolutely. I think if anybody has any questions about Blackfish engineering or this V&V approach that we've developed with our clients, feel free to reach out to us. Tim and John are available for consults, and the information is available there on the screen. Thanks very much.